Today we are going to understand VLAN traffic over carrier Ethernet transport network. So when you are working in telecommunication, especially for enterprises that have transport or wide area network, you have the physical network. It could be optical fiber, or it could be microwave communication, or it could be satellite. Although nowadays most of transport networks in the world are optical fiber. So so when you have that transport network laid out and implemented, uh, they are like a pipe. Okay, so you need to run some protocol that will carry the traffic from point A to point B across that transport network. And today we are going to consider carrier Ethernet. And when you are using carrier Ethernet, you have built-in integrated switch into the equipment or transmission equipment, and you can configure VLANs from all the from point A to point B to carry the specific traffic. That's what we are going to see today. Let's get started. So before we go into the lab, we are going to use a packet tracer. We are going to have some few theoretical concepts. So carrier Ethernet has been around for so long, and very many operators today use it. It's very simple to implement. All you need are switches, external switches, or mostly nowadays you integrate the switch into your transport network. So they have got many applications in the cellular networks. You can use to backhaul traffic from 4G, 3G sites to the core network. You can use that. You can use as a backbone network to connect it to remote sites, or sometimes you can use as to provide internet to customers. So normally you are going to configure VLAN, and that VLAN is going to carry the traffic across the carrier Ethernet transport network. It has also got other features, although some operators I have worked with, they don't use it. But it's still very helpful in terms of maintenance and troubleshooting. You can have OAM, a feature that you can use to monitor the network, troubleshoot in case faults occur. Uh, so normally it's compared with an IP network. An IP network is very easy to troubleshoot. You can use utilities like Bing, traceroute to locate the location of the fault and test also the reachability when using Bing. We got similar functions in the carrier Ethernet, and they are part of the OAM. So because in IP network, your traffic is sent as an IP, but in the carrier Ethernet network, traffic is sent as a MAC address. So devices across the transport network, the switches, they talk to each other using MAC addresses, and so you can ping the MAC address, you can trace through the MAC address. All those features, they come under the OAM, and it is very easy to troubleshoot and also implement. And they will also help you to maintain your network, especially when you have a large transport network that has over 20 or 50 sites. Carrier Ethernet is also scalable. You can expand your network anytime you want by adding switches, configuring additional VLANs. In the carrier Ethernet, you can also achieve a multi-gigabit speed. That will be very useful in case you wanted to transport 4G traffic, and nowadays 5G traffic. You can implement a 10 gig carrier Ethernet network. And as your capacity demand increases 10G, 20G, you need to use optical fiber transport network, because optical transports, they have much higher capacity compared with terrestrial microwave links. So with this brief introduction, let's go to our scenario and lab and how and see one example of how to configure the carrier Ethernet. So in this example, we have four sites. This is our telecom company, and they are connected to the internet at this site, Mogadishu. They have also got other sites. So you as a network engineer or transmission network engineer, you are assigned a simple task to to connect Hargeisa, this remote site, to the internet, and also all these other sites. Okay, so behind each switch there is a data center where there are users, employees, customers, so that so this is the the provider the operator equipment, but the internet is going to be distributed to all other people, customers in the city. So that's what we are going to configure, and using carrier Ethernet we are going to carry this internet, create this internet pipe or this internet connection using VLAN 100. So you have assigned VLAN 100 for the internet transport, and you are also asked to you are also told that the capacity that you are going to transport to Hargeisa is 20 Mbps internet. So this is now our lab. Let's configure this lab using our bucket tracer. Before we go to bucket tracer, please know that in in uh, in scenarios like this, using carrier Ethernet and using VLAN to carry the traffic, the what you are going to do is that basically you are going to create this VLAN 100 across all the switches, across all the sites. Okay, and you also to make sure that link is, or whether it's optical fiber or microwave, between the sites or between the switches are going to be configured as trunks. So this is a trunk, 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 and because customer is connected or the internet is connected to this port that's connected to the internet server, maybe there is internet server here, or internet connecting device or a router. You're going to you're going to maybe assign this one as an access port, because this is the ingress port. This is where the traffic is going to be sent. So normally here we are talking about computers here. It doesn't matter whether you have a switch, whether they are connected to another switch. So this port you are going to make it an access port. When you are connecting to other switch in the data center of this company, that's when you will configure as a trunk. But for this test, you are going to configure this as an access. So because this port you have made it an access, you need to add as you need to associate that port with VLAN 100. So we are going to add this port as a membership to this VLAN. Also, the egress port where the traffic is going to exit the internet traffic at this site on the remote side, you are going to configure also as an access port and associate it with this VLAN. So let's start. It's very, very simple. How many switches do we need? 1, 2, 3, 4. We have 4 sites. And to test the internet, right now we are going to connect the computers, and after the configuration, try if they can reach each other. Once they can reach each other, that means the connection is working and you have done your job very, very well. So we go to switches. Let's use layer 3 switch, 35th to 3560. So switch 1, switch 2, switch 3. Let me check again. How many sites do we have? We have 4 sites, right? That's good. So let me add one more, which is the remote site. And then you are going to connect with your transport network. It could be optical fiber, microwave. For this lab, let's use short Ethernet cables, because we are simulating that they are very close, even though they are not very close. This could be 50 kilometers apart across your transport network. And then you connect it automatically, and then you connect from this side to this side. And to test the connection after the configuration, let's use test the computer. So there's one engineer will connect to the computer here, and another engineer will connect to the computer here. Even though you don't need another engineer here, because switch the LAN MAC address, as we say. So when this engineer who is doing the configuration send this traffic across the network, then he should, when the travels across the switch, if the link is working, this switch should learn the MAC address of this remote switch, and this guy engineer should see the MAC address of this remote switch on the MAC address table of this switch he is connected to. So that's also another way. So you don't need another engineer to work with you. And but if you can get it, it's the best. Yes, it is best. It's best because you can also run. You can test the bandwidth, whether it's at 20 MB or less than, using internet hyper utilities. There are utilities that on the internet that you can test the bandwidth by making this is a client and server and trying to download and upload some files using FTP protocol. So that is an additional thing that you can do. So let's connect our computers to the to the carrier Ethernet network. So we're going to use automatic connections, but you have to specify which port is you want to connect to when you are working on real projects. So our task was to configure VLAN 100. Let me write it in here so that we all be on one page. This is VLAN. We need to carry VLAN 100. Name is 20 Mbps internet, and that's what we are going to do right now. So let's configure this VLAN on all our switches and see if everything is working. So we start with this site Mogadishu, and we are going to add this let's no enable. Let's see which VLANs do we have. When you are configuring VLANs, even though we have assigned VLAN 100, you have to make sure that VLAN is not already being used. Okay. So the best practice when you are working on network is to first verify that everything before you start even the configuration. So let's go see what VLANs do we have. Show VLAN brief, and if you look at here, we have only the default VLAN. We don't have another VLAN. All the ports they are associated with that VLAN. So good, we don't have VLAN 100. We can use it now. So let's say config, go to global config mode, and let's say VLAN 100, and let's name it 20 megabit per second internet. That's all. So we exit again. Now let's verify if the configuration has taken effect. Show VLAN brief, and as you can see, the VLAN has been configured. But this VLAN will not be effective unless you add ports, membership ports to the VLAN. So what do we have here? We have now the port that is connected to the computer. For the test, we are going to make it an access port, which is fast Ethernet 02 on this switch Mogadishu. You have to name your switches according to your plan, and this port fast Ethernet 01 going to the other side. We are going to make the trunk. So let's do that. Conft interface fast Ethernet 02 interface fast Ethernet 0/2. That's the access port, switch port, mode, access. Then we are going to associate with VLAN 100. Okay, this is the way you are going to do on Cisco switch. And let's also test. Let's also configure the other port, interface Ethernet 01, switch port, mode, trunk. And he has refused it because he said the trunk encapsulation is auto. Unless you change from auto, you cannot make this port a trunk. You know the encapsulation protocol .1q. So let's say that switch port trunk encapsulation .1q. Now let's run switch port mode trunk, and now it has taken effect. So this port has now become a trunk. Let's test again. Let's verify it again. Show VLAN brief. As you can see, VLAN 100 we have associated with port fast Ethernet 02. That's the port we have used it for PC connection to test the connectivity, end-to-end internet connectivity. We also, as you can see, this port is fast Ethernet 01 is missing. Where it has gone, it has become a trunk. So you know how to do that. Show interface trunk. As you can see, port fast Ethernet 01 now it's a trunk. Status is a trunking. It means that we can only connect that port to another switch. We are now done with this side. Mogadishu. You need to name your switches because that will make it look like more professional and more easy to identify which switch you are in. We go to next. This switch on this side, both of this interface are going to be a trunk because they are connected to another switch. So no conf enable to go to enable mode, conf t to go to global configuration mode. So we can say interface fast Ethernet 01. Let's use, instead of configuring one by one, let's use the command range so that we can configure at the same time. Fast Ethernet 0/1-2 switch port trunk encapsulation .1q switchboard mode trunk. Now both of them are going to be a trunk. We can test it by running the command show interface trunk, and as you can see, fast Ethernet 01 and 02 are on, and they are now trunk running on the .1q protocol, trunking protocol. Have we added the VLAN? No, that's also a mistake. Let's add the VLAN 100 because the connection will not work. So VLAN 100, let's say name 20 Mbps. You have to name it internet. That's all. Show VLAN 100, show VLAN brief, and VLAN 100 is now there. As you can see, 20 Mbps. It's active. We are not going to associate with any port because this VLAN will transfers across this switch asset using this trunk port. So trunk means it will carry all VLANs. We can have VLAN 200 and other VLANs for other surfaces, so they will all travel across the trunk links. Trunk links will also carry the native VLAN for VLANs that are untagged. Okay, we are remaining with only two switches to finish this task off. Normally, depending on the size of your transport network, you need to prepare a script so that you can copy and paste on your devices instead of running the command one by one as we are doing right now. Conf t interface. So in this switch we also have fast Ethernet. Let's use the command range fast Ethernet 0/1-2 switch port trunk encapsulation .1q switch port mode trunk, and we are done. Exit. Let's add VLAN 100 name 20 Mbps internet. That's all. Last but not the least, let's go to the final site, Hargeisa, and click on it, and let's configure it all similarly. We go to CLI, no, enable, conf t. We have two interfaces now. This interface fast Ethernet 02. We are going to make it an access, leave it as an access because it's connected to a test PC. Okay, we are not going to make it a trunk. Only this board we are going to make it a trunk. Fast Ethernet 001. So switchboard trunk encapsulation .1q switchboard mode trunk. We are done. Let's create VLAN 100 name 20 Mbps. Internet, leave it like that. It's okay. So exit. Let's go to interface fast Ethernet 02 and add it to VLAN 100 as an access port. Okay, switch port access VLAN 100. That's all. You can test it. So VLAN brief, and as you can see, it's working. Now let's test. Okay, now the configuration is finished, has been finished. Let's assign an IP address uh, to this computer. Because we are using a carrier Ethernet, you can simulate it as a one big switch. Even though we have so many switches, you can simulate it as a one big switch where the end remote sites are now connected. So we can use the same subnet for both of these computers. When you have routers, this when you can use a different network. So I will start with this PC, and I'm going to use it 192.168 class C IP version 4 address. So that's what we are going to do. 192.168. Let me use .1, and let me leave the default subnet mask as it is. I will come to this computer also, which is on the other side of the link, and also assign the same subnet 192.168.1.2. Now let's try to see if they can reach each other. Once they can reach each other, then we can say that the internet connection is working, and the people on this side, the users on this side, can now use the internet that was connected from Mogadishu, from the other side. So you know how to. First thing, you have to check if your computer network setting is okay. Yes, it is. You don't need a default gateway because this is a switch layer 2 network 168.1.1, and as you can see, we can reach the other side, which is quite good. So the internet is now working. The internet was on this side. Now users on this side can use internet. Okay. Also, users on this side, they will be able to use the internet. If there are users behind this switch, they will also be able to use this internet. So what we are going to do is that if you used another port to connect it to users, make that port an access, and make sure it is in membership of VLAN 100. Okay, similarly for this, and this is the way you can create, you can configure, you can carry VLAN traffic over carrier Ethernet network. I hope I explained it well, and I hope you learned it from it. Thank you so much.